This is part 8 in the series of videos in which I'm attempting to repair this Wren executive computer. In the previous video I got as far as showing some of the self-tests were now running, but that it was failing on the UART loopback test, and that came down to, or at least initially came down to the fact that the device wasn't being selected and there was something going on with the in-out decoding, so that none of the peripheral devices were ever being selected. So I went through the decompiled code and created a list of all the ports that it used, and then I started working my way back through the most promising ports that may be causing issues, and in particular working my way back from the chip enable line of the UART that was responsible for the test failing. I got fairly lucky and fairly quickly found a 7.4 LS32 that had failed and had been replaced. The machine's not working, but the UART is now being selected. So if we look at the UART again, I've got the scope connected to the chip select line of the UART, and if we have a look at the signal now coming on that line, so we'll do a single shot capture, and you can see that it is now doing what you'd expect. The chip is being selected, and it's doing that quite reliably. It will do that every time now, whereas previously we were getting no activity on this line whatsoever. We're now getting exactly what we would expect as part of the self-test. However, the machine's still not working, and it's still failing the same test. There are a lot of failed devices on here. That's kind of typical when you get a power supply failure, and the devices that tend to suffer most are the large-scale integration devices. Unfortunately, one of the design features of this particular computer is that although there is a buffer, which is the one I've got the logic analyzer connected to so you can't see it, there's a buffer between the Z80 and the data bus that feeds all the peripherals. There's only one buffer, and all the peripherals are connected together, at least in terms of their data bus, on the outside of that buffer. And so a failure of any one of those devices will could pull the data bus down for all the others. But as we're now getting activity on the UART chip select and still getting a failure, I started probing around the data bus lines going into the device. And if we look at the data going in, I'll just grab this probe. So if we look at the data lines, I'll just select one. A single shot capture so you can see more clearly. You can see that the quality of the data on that line is not at all good. Now, it's not all that unusual when you get old buffers driving lots of chips that the signal level's fairly poor, but as you can see here, it's looking particularly bad, and there's always a possibility, of course, that the quality of the data going into the devices is not sufficient to properly drive them. Now, what I've done is taken out as many of the other devices that share that data bus as I can without the self-test failing up to this point. One thing that's very strange on this machine is if I take out the floppy drive controller, then the Z80 refuses to start up at all. I haven't really looked into that yet. It's possible that it's feeding one of the control lines to the Z80, and that's preventing the Z80 from running. But this floppy drive controller is on the same data bus, so it could be that this is the culprit. But what I wanted to do is just see if we were getting any discrepancies between what was going into the buffer driving the data bus and the data that was feeding the peripheral devices. So I'll move the camera, we'll go back and look at the logic analyzer and see what data is going through that buffer. Okay, so we're looking at the logic analyzer. I hope you can hear me over all the noise. And what I've done is used POP3 to create two 8-bit data inputs, and I have these two inputs connected as the A and B inputs to the buffer chip. Okay, it is a 74 LS245. You're probably familiar with these, and it's just an 8-bit bi-directional buffer. I've defined the two 8-bit values as data A and data B, and that's what these two values here represent. If we look at the waveform, I've got them included, as you can see, as data A and data B, and I've included them as bus values, so we don't need to look at the individual lines. I also have the RAM chip select line connected to the chip enable line of the UART. So the way the trigger's set up is I'm again using trigger A, but I have it configured so that the only value we're interested in here is when the chip select line goes low. Now I could look at other values, addresses, the sort of thing, which I may do later if I need to, but right now all I'm interested in is just capturing the data that's going into the device when it's selected. So what we'll capture is chip select line will go low when the device is selected. The data A value is the data being fed into the buffer from the Z80, and the data B value is the output value of that buffer that's going to all the peripheral devices. So the Wren is running, so I'll arm the analyzer, I'll press reset, and it should cause the device to be selected as part of the self-test. So I'll just press reset, it might take a second or two, and as you can see we've now captured some data. As you can see straight away we have an issue, so the chip select line has gone low, but the data going into the buffer is 02, so that's just 1 bit should be set, but the data coming out is 82. If we scroll across and look at some more data, so we'll go across to each instance of chip select going low, and that's the point at which the device is being fed data. So the next one, 87, 87, okay, that doesn't prove much, it was the last bit that seemed to be stuck anyway. Same here, that's an 8. And the next one, 06 going in and 86 coming out, so it appears as though bit 7 on that data bus is stuck high. Let's see if we can find any more. So the next one, again, 0 value going into the buffer and a value of 80 coming out onto the peripheral data bus. It's not showing as stuck on the scope. It is actually showing that it's toggling, and in fact that's the one that we looked at on the scope, but I think what's happening is it's just not of sufficient drive to be able to quickly pull the line down to give it a reading of 0 when it should be. Bear in mind that that bus is normally floating. It's also possible that the floppy drive controller is faulty, that's what's causing the problem, but unfortunately I can't take it out because it stops the Z80 from running. But what I will try next is just lifting the data 7 pin and see if that allows the Z80 to run, and see if we still get this issue. So I'll just do that off camera, and then we'll come back and have a look to see if that does stop this bit being stuck. Okay, so I've lifted the data 7 pin on the floppy drive controller. The Z80 is still running, but the test is still failing in the same place. So we'll run this test again and see if we get the same results. Okay, and we do. We're still getting bit 7 stuck. We'll go across and just see if it's consistent. And again, should be 06, it's 86. And it should be 0, and it's 80. I'll just re-trigger and make sure it does the same thing each time. Okay, and just as a sanity check, I'll just check to make sure this is not a fault with the pod on the analyzer. So what I'm doing now is I'm just disconnecting the bit 7 pin on the data B bus that we're looking at, and disconnecting it will be pulled to ground, so it should read 0. So if I now rerun the same test, see if that changes, it should go to 0 now, and indeed it does. You can see that it went from 80 to 0, and I'll do the reverse. I'll reconnect the lines. We've now got data bit 7 reconnected. We'll rerun the test and see if it goes back to 80. And it does. Okay, so it looks fairly clear here. We have a problem on the peripheral data bus. It's not a hard fault. As I say, the line is switching, so I need to see if it is just as simple as the buffer is starting to fail, or if there's some other device on that bus I haven't found yet. But I'll have a dig around, try and track down anything else on that particular data bus, and if there isn't, I'll swap the buffer and see if that cures the problem.